Second half of 5.4, we're going to solve with some sum and difference formulas. Okay, find all solutions over the interval 0 to 2 pi. We're going to separate this out just like u and v, u and v. It's going to become a very big expression before it becomes smaller. So this one is the u plus v, so this becomes sine of x cosine pi over 4 plus cosine x sine pi over 4. That's the first half. Plus, now my subtraction formula, sine x cosine pi over 4 minus cosine x sine pi over 4. Okay, and if I add these together, first of all, let's do sine x cosine of pi over 4, radical 2 over 2. Hopefully you can see that this term is going to cancel out with this term, so we no longer need to worry about it. And then we're going to add sine x cosine pi over 4 is radical 2 over 2. So now I have two of these together. They're exactly alike. 2 sine x times radical 2 over 2. These 2's are going to cancel. Now I have sine x times radical 2 equals negative 1 from the original. And now you've got it down to solving just like you were used to. Divide by radical 2 would be sine x equals negative 1 over radical 2. So where does sine x equal negative 1 over radical 2? You need to realize that that's the same as negative radical 2 over 2. Sine is negative radical 2 over 2 in quadrants 3 and 4. So x equals 5 pi over 4 and 7 pi over 4. Okay, solve this one, spell it out. It's going to get very big, but then it'll become smaller. Okay, there's the finished answer. Spell it all out, substituting your u's and v's in there. Sine of 0, or sine x times 0 is going to be 0 over here again, so they're going to fall out. Cosine of x times 1 is just cosine x. Minus cosine x times negative 1, that's where the plus comes from. Add them together, 2 cosine x equals 1. Cosine x equals 1/2. Happens at pi over 3 and 5 pi over 3. Okay, try this one again. It's a little bit different, but it's very similar. You just have a multiplier of 2 and a multiplier of 3. Start by expanding it with your u's and v's, and we'll go from there. Okay, plugged in my u's and my v's. Now I'm going to simplify what's in parentheses. Try it on your own, see if you can get the same answers. Okay, we get down to here, where our sine x times zeros have fallen out, or 0 times sine x has fallen out. This was a negative tangent divided by 1. And the negative tangent becomes subtraction, so 2 cosine x minus 3 tangent x. In order to solve this, we're going to have to get common denominators. So that means cosine's going to stay. 3 tangent is going to become sine x over cosine x. 2 cosine x, in order to get common denominators, we're going to have to multiply by cosine x over cosine x. So now I'm going to have 2 cosine squared x minus 3 sine x over cosine x. When a fraction equals 0, we no longer have to worry about the denominator. It doesn't matter what it is as long as our top equals 0. And I needed an all-in-one trig function, so we're going to substitute cosine squared with 1 minus sine squared x minus 3 sine x equals 0. So now I have 2 minus 2 sine squared x minus 3 sine x equals 0. And then we're going to need to rearrange and factor. So now this is going to be negative 2 sine squared x minus 3 sine x plus 2. That is going to factor into, I don't like factoring with a negative out front, so I'm going to factor out the negative. It has no effect on if my equation equals 0, as long as all my signs are changed the same. So 2 sine squared x plus 3 sine x minus 2 equals 0. If I'm factoring, I know I've got to have a 2 sine x and a sine x. And then I'm going to have 2 and 1. 2 is going to go here to make 4. That's going to have to be a positive 4 and a minus 1. Set my factors equal to 0 and solve. Sine x equals 1/2. Sine x equals negative 2. Sine x is 1/2 at pi over 6 and 5 pi over 6. Sine x is never negative 2 because it only goes from negative 1 to 1. So quite a bit longer problem. It's going to be it's going to be your hardest one you're going to come across.